Hello viewers, welcome to my channel PC Geo Kimberlite, a source of diamond. In this video, we are going to see an important topic from paleontology. That is as per the syllabus of SPPU, Savitribai Phule Pune University, paleontology. And from that paleontology, we are going to see the first, we have a class Lamellibranchia and the phylum is Mollusca. Phylum Mollusca, class Lamellibranchia, in the terms describe the hard part morphology of Lamellibranchia. Yes, in this category we are going to see, because we are the geologists, so we are just dealing with the hard part. So here we are going to see only the hard part morphology of Lamellibranchia shell of class Lamellibranchia, or it is called as Pelisepoda, or it is a phylum Mollusca. Now, then you are going to see in the examination where we have to write down the systematic classification of this Lamellibranchia. So first what we are going to write, the broad what we have, the division what is there, that is the kingdom. That is the animal or plant. So here the kingdom is the animal. Then sub-kingdom is invertebrates. In the animal, this particular Lamellibranchia or Mollusca is there, invertebrate. What is meant by invertebrates? So we are the vertebrates. So what is that vertebrates are there? We have a hard backbone is there. So in vertebrates, the backbone is the bone which are there, it is absent. Without any backbone, this called as, the group is called as invertebrates. Now it has been divided into the phylum Mollusca, that is the soft body animal, and the class we have the Lamellibranchia. Lamellibranchia, there is a two words, lamelli and branch. So here lamelli means the leaf, branchia means the gill. So the gill of this particular Lamellibranchia is look like as what we have the leaf shape. It possesses the leaf-like shape of gills, so it is called as a branchia. So Lamellibranchia, Pelisepoda will be there. Another name which will be given. Now here the very important one, first basic one. Whatever we are going to see this particular Lamellibranchia shell, they are the shells are there. They are the, what we have the hard, they are the calcareous in nature, and they are made up of two walls. Yes, you have the two hands are there. If you join them, these are the two walls. Exactly going to match, whether you can see from the front or whether you can see from the back. If you join them, they are exactly same. So this is the content, two walls, the left wall and the right wall. So that is the important part will be there. Now we will draw the diagrams which will be required, because we have to explain now various terms which are there. So you have to roughly draw the sketch, and then here in this particular diagram, is just I have made the rough diagram. So here you can see now whatever just outline I made, then I make the fair things. Yes, little bit. Yes, whatever the distance is there, that has to be there. Still, yes. Yes, so this is the way you have to draw the diagram. Yes, you have to make it out at every level. You can check it out from the distance. How much is distance is there? Yes, so you can check it out both sides. So once you have drawn the vertical line, there will be the equal part. So here we have the two walls. This is your left wall and this is your right wall. So this is the first important point about the Lamellibranchia is there. It is contained the two walls. One wall which is coming on your left hand side, it is called as left wall, and whichever the wall which is coming on your right hand side, it is the right wall. Yes, so both the walls are equal. So the first term, important term about this particular shell is that these are equivalved. Yes, for this, the two hands are there, left hand and right wall. if you join these left and right palms together, now you will see the perfect shape. What we have drawn the diagram is, what we have here, we have the first depression which is there. This is called as a lunule. This is the elevated portion. It is called as umbo. And this is again depression. Shcll. Yes, so that is the differences are there in the brachiopods and lamellibranch. This is already the video has uploaded on my channel. That is give the similarities and dissimilarities or distinguish between the Lamellibranchia and brachiopod shell. So here, if we join these two hands, yes, there will be first depression, that is the lunule, and these two elevated portions, these are the umbo, and in between again here we have the depression. I bring it very close, you can see now. So no need to remember the diagram here. Here you have to remember your hand and you can get this complete figure. So when you measure the distance between the left and right in the center, so this will be called as the breadth or thickness of the shell. This is the thickness of the shell. So now equivalved we have seen lunule, umbo, breadth or thickness and shcll. And this is the commissural. Yes, this is the plane with joints together. This is the commissural. Now we'll go for the next diagram. Single wall we will take now. Yes, little bit, not pointed, it should be somewhere. Yes. Now the middle portion, everything what we have made the small changes, do it perfectly. The diagram should be a perfect one. Yes, we have been drawn this particular wall. Now this is the wall. Yes. The pointing now, this is what we have. This particular part is umbo. Yes, that is the umbo side what we have in this particular one. Then parallel to this dorsal margin, this is what we call as the dorsal side. This is the dorsal side. This will be your ventral side. I don't write on the lower side, so we could not see. So here this is the ventral side, and umbo pointing whichever the side is there. That is your anterior side, and of course it is your posterior side. Yes, that will be grooves are there, depressions will be there, and here we have the hinge line which contains grooves and sockets. On the both the walls it will be there. So left wall and right wall, they contain these particular what we have, the grooves and socket on the both the side. Yes, come to the next one in this. If we divide dorsal to the ventral in the center, if you draw a vertical line, the shell will be divided. Yes, everything will be going to draw. These are the two muscle impressions. Yes. The grooves will be running whatever we have, this perineal line. This is what we have, the perineal line. This is the anterior adductor muscle impression. Here we have posterior adductor muscle impression. So now these are dividing, but what is happening here in this case, the umbo is coming on one side, the other side we don't have umbo. So here this particular wall which is there is inequilateral. So this is the equivalved. Lamellibranchia contain two walls, both are equivalved, but if you take the one and if you draw the vertical line, umbo will be one side. If you make out that particular point, I'll show it you with the, yes, with the protractor I can show you. If I draw this part. You can see now. In the center, if I divide, what is happening? Umbo on one side, but other side it is don't have. So it is the inequilateral. Yes. The next one part, the shell is inequilateral. So when you are going to break out the brachiopods and lamellibranch, similarity, dissimilarity, it is required. Next one, dorsal to ventral. If you measure the distance now, instead of the perpendicular, yes. If you measure the distance dorsal to ventral in the center, this is called as, right on the outside, this is the height of the shell. This is the height of the shell. And if you measure the posterior to the anterior, if you measure the distance posterior to the anterior, this is called as the length of the shell. This is the height of the shell, this is the length of the shell, and left to right, this is the breadth or the width of the what we have, the lamellibranch. This is clear now? Yes. I'll write it out, then again we'll go with the same diagram. So here we are seeing the inequilateral, then the height of the shell and the length of the shell. Yes, lower part might be sometime it goes out of the screen, no problem, but diagram should be neat and representative one. Yes, so umbo should be drawn. Yeah. This is what we have parallel to the dorsal margin. Running parallel, that is the hinge line is there. This is the dorsal side, umbo pointing anterior side. If umbo pointing this side, then this will be anterior and this will be the posterior. Remember that. Then there will be two muscle impression. We'll see the various types of muscle impression also. So here anterior adductor muscle impression, this is posterior adductor muscle impression. So this is there. Then this is the line. These two muscle impressions joined by a line, a smooth line running parallel to the ventral margin. It is called as pedial line. And this pedial line towards the posterior side, it shows a Z-like shape. It is called as pedial sinus. Clear now here? Dorsal, ventral, anterior, posterior, parallel to the ventral margin running the hinge line, grooves and sockets are there. Two muscle impression, adductor muscle, anterior adductor muscle impression, posterior adductor muscle impression joined by a line, simple line running parallel to the ventral margin, and towards the posterior side it shows a Z-like shape. That Z-like shape is called as pedial sinus, and the remaining line is called as pedial line. So this is what we have, the various parts. Clear? I think this up to here it is clear. Now next one we are going to see now, might be in the examination they may going to ask you a separate one question. Give the different hinge lines in the lamellibranch shell, or give the different muscle impressions in the Lamellibranchia shells. So we'll see now one by one these parts. First one, we'll see the hinge line. These are called as domes. Yes. So what we have, the first one, it is the texodome. The simple common one what we have, the texodon. What is a texodon? Where whatever the teeth and sockets which are there on both the walls, they are numerous in number. They are large in number. So automatically what is happening? The size will become the small. Yes, the grooves and socket which are there on both the walls are large in quantity, and due to that large number, their size will become reduced. This is called as the texodon. Come to the next one. The number has reduced. For example, texodon. What we are taking? A classroom is now containing 50 students, but there 100 students has come out. So whatever the space which is there for sitting on one chair bench will be two. I think two are there. Then that has to be shared by 4. So what is happening? Each student will get a very small half. Whatever the full space is there, now he is going to get the half of it. Then that the size has reduced. That is the texodon. Now caesodon, there is a 50 capacity of the student is there, but now the student has come only 20. Number is less. So whichever student want anywhere they can sit together. But when 50 or 60, 100 is there is no choice. So they have to compact together. So caesodon, the number has less. So once the size number has reduced, the size will be increased. So that is the caesodon. Then the next one, isodon. Iso means equal. Whatever the caesodon's size is less, few in number, the grooves and sockets are equal in size, then it is called as isodon. If they are unequal in size, one bigger, one smaller, heterodon. See now, one by one. Texodon, large in number, size is small. Texodon, less number, large in size. Isodon, less in number, bigger in size and equal. Whereas heterodon, less in number, bigger in size, one big, one small. So they are unequal in size. That is the heterodon. Then come to the next one, we have desmodon. Desmodon, that means it is reduced or it is completely absent. The hinge line is completely absent. Disodon. What is example? I will give this particularly disodon. Whenever a small child is there of 7 or 8 months or 9 months, just it is a gum line is there, yes. So there is no teeth, but the gum line is there. So that's what we have. The simple, sometimes maybe 1 or maybe 2, just they are started. So simple teeth will be there. That will be the what we have, the disodon. And we have seen the one more is there, that is the pachydon. But this will be the question will be there for 5 marks. So at least you have to write the 5-1. Now pachydon, very large teeth. Large teeth is there, size is less, number is less. Large teeth is there, but each teeth is a blunt and heavy. That is the important character of the pachydon. This is clear. Texodon, caesodon, isodon. This is in sequence you have to remember. Texodon, number will be more in number, size is less. Come to the next one. Number is reduced, size will increase. Then if they are equal in size, number is less, equal in size, that is the isodon. If they are unequal in size, heterodon. Then the desmodon, what we have, totally the hinge line will be absent. Simple reduced gum will be there. The disodon, desmodon, we have just the gum or maybe 1 or 2 small teeth will be there on that particular part. And pachydon, the teeth are very large, blunt and heavy. So this is a part might be asked as write a short note for 5 marks. So you have to write down or you can draw the diagram. Here I have not drawn the diagram, but you can show the diagram also. This particular part I have been discussed in identification of parentology part 1 and part 2. In the part 1 video, I have discussed these particular pictures, the diagrams which are there I have been shown. The next one we will see the what we have, the muscle impressions, that is called as myria. Muscle impressions are called as the myria. Now in this myria we have the one by one, we'll see monomyria. Myria is the muscle impression. If it is one, it is a monomyria. For example, in the practical we are taking the pecten. So pecten just have in the middle center one, it is the single, so it is a monomyria. If the number is 2, it is the dimyria. 2, but they are equal, isomyria. They are unequal, they are the heteromyria. See, simple: monomyria, dimyria, isomyria, heteromyria. So this is what we have about the muscle impressions. I'll show you some examples. Yes, here we have the pecten. Now you can see the muscle impression. Where we have the muscle impression is there, we have written the number L3B. Yes, monomyria. The similar specimen. Here also the same one, the number where we have written, there is the little bit the light yellowish color is there, so that is the one myria is there, the monomyria. Yes, here also very clear, the pecten, one muscle impression. So we have 3 samples, so I have shown all the 3. Now this is what we have, the 2, left and right, yellowish color is there, and you can see the hinge line, the umbo prominent one, and what we have, the diagram which we have drawn is the 2 muscle impression will be there. So I think this will be clear. This will be, one will be here and second one will be this part and this part. So 2 muscle impressions. And now I can see the same shell which we are going to make out. You knew this is, yes. I have shown this diagram, I have shown this way. So this is the way, the left and right, the breadth will be there. And if you turn it out and check it out, yes, umbo will be here, the luteal and eschaton. So these are very, very clear one. Equivalved is there, left and right wall. Now very important one, both the walls, left and right, grooves and socket. This is socket, groove, socket, groove. So both one, left and right wall, they are joined towards the dorsal side, and there will be opening will be there from the ventral margin. So shell is going to open from dorsal side. There is a hinge line. So along the hinge line, they have joined along the ventral margin. You can see now through the ventral margin. You are going to see closing and opening, and this closing and opening will be done by the muscle impressions. So the muscle impressions are helping this particular closing and opening of the shell. So this is the what we have, the hard part morphology. Now we will go to the external one. Now what we have, the external one. In that external, when you are going to see now, first one, whatever we have, the shape is there. More or less they are the triangle or elongated shape is there. I will draw the pecten now. Yes, yes. This is the pecten, reverse one, from the dorsal to the ventral. This is the radiating lines, and there will be the another concentric lines. And this is the auricle, or it is simply called as ear. Auricle, or it is called as ear. It might have one, or it might have 2. I'll show you the both example. Yes, you can see now here, hinge line is coming out. This is one auricle, and this is the second one. At the same time, you can see radiating line from the dorsal, it comes to the ventral margin, and you can see the outline is smooth, sometimes curvy, and you can see the radiating line is there. Color is also an interesting one. Yes, you can see now here, it is I think clear one. Radiating line, suture line will be a zigzag. Yes, zigzag will be there, you can see, very clear. Yes, and if you make out that part, I'll try to show you all the details. Yes, auricle is there here, and similarly this particular shell, you can get this one. Yes, radiating is a vertical line dorsal to ventral and the concentric line. Now in addition, I'm going to show you this important thing where the concentric line and radiating line join together. From their part, what we have, the spines are coming out. Yes, you can see very carefully, this is the already mounted now on a glass angle with carefully. They are opening, we have been shown, and the pearl is there. Not a real pearl, but this is the way the pearls are there within this particular shells which are there, which have been shown. Now the next part which is there about the geological and geographical distribution of this particular Lamellibranchia. If you see this particular part, if a geological part, these phylum mollusca and class Lamellibranch, they are starting in the period of Middle Cambrian. So Middle Cambrian they have started, and in the middle Ordovician they are diversified, fully diversified there in the middle Ordovician, but they travel Paleozoic, Mesozoic, Cenozoic, and they are present. So in the genera there will be changes as per the climatic condition, environmental condition. Some are could not adopt, they will be there. New species will be adopted, so that will be there. So evolution has taken place, and till today it is there in the present. And whatever the hard part is there, it is made up of the calcite which is there. And very interesting one, all over the world it has been present, and most of them are the marine and few are the fresh water. So that is what we have. All aquatic environment is there, environment which are there, that is the marine abundant one. And addition, we are going to get that is the fresh water also. So this is what about the phylum Mollusca class Lamellibranch. I hope I had tried my level best to explain you on the board and chalk. I have already been done the PPT, and I have backed the video identification of Lamellibranch 3 specimen. We have taken the Unio, Arca, and Pectin, and there itself I have been described the morphology in the identification of fossil. But today I have taken as a separate video for the theory, and that will be helpful in your practical. I hope this is clear from my side. If you have any queries or doubts are there, please write on the comment section so that I can answer your queries. Thank you. Have a nice day.